X-rays. When a stream of very fast high-energy electrons strikes a metallic electrode, anode, the electrons are slowed down, and some of them penetrate into the metal. The sudden breaking of the electrons produces an electromagnetic radiation of very short wavelength, X-rays or Röntgen rays. This radiation is generated by electrons penetrating into the metal and interacting with the metal atoms. It shows well-defined wavelengths which are characteristic of the structure of the metal, forming the anode. A high-energy electron which penetrates into the metal atom may dislodge one of the inner electrons of that atom. The vacant place is taken by one of the outer electrons, which thus leaps from an outer to an inner shell, and in doing so, emits energy in the form of radiation, i.e., X-rays. These rays were discovered by W. Röntgen, a German physicist, in 1895. Their nature was unknown to him, and he accordingly referred to them as X-rays, name which has persisted more particularly in the English-speaking countries. Technical forms of construction of X-ray tubes. As a rule, the stream of electrons, such electrons issuing from a cathode are called cathode rays, is not directed against the actual anode, but against the anti-cathode, which forms a target for bombardment. The impingement of the electrons against the anti-cathode causes the latter to become very hot, and it may be necessary to cool it or to design it as a rotating anode, so that the cathode rays are always beamed on a fresh area of the anode surface. Because of their short wavelength, 108 to 10 to 12 centimeter, X-rays can pass through objects which are opaque to ordinary light, and shadow images of such objects can be made visible on a fluorescent screen coated with barium platinocyanide. When X-rays pass through crystalline substances, diffraction phenomena occur which reveal the wave character of this radiation. An interference pattern, composed of a regular arrangement of dots, can be formed on a photographic plate, and these provide information as to the crystal structure of the material concerned. Such diffraction patterns were first studied scientifically by M. von Laue, and they are known as Laue X-ray patterns.